Okay, so we talked about, last year we talked about taking positive exponents, how to evaluate them, like 7 squared or 2 to the 4 or 5 to the 0. Last week, we learned how to do fraction exponents, okay? How we have to change them to a radical to find what the answer is. This last one we're going to look at, the exponents we haven't covered. What happens if we have negative exponents? So let's look at it 2 ways, and let's look at this as an example. Let's say I ask you to divide 3 to the 2nd by 3 to the 5th. You can write that 2 ways. You could write it like this. Well, 3 squared is 3 times 3. And I'm going to divide that by 3 times 3 times 3 times 3 times 3. And I can cancel out some 3's on the top and the bottom. 3 divided 3 is 1. And anything times 1 is still the same thing. So I can just cancel that pair out. Another pair cancels out to 1. What am I left with up top? I'm left with 1. Not nothing. 1. Because remember, we're dividing each of these by 3. So 3 divided 3 is 1. 3 divided 3 is 1. So the answer would be 1 divided by whatever 3 times 3 times 3 is. Or 1 divided by 3 to the 3rd. Think of your exponent laws. Whenever we divide 2 powers, what do we do with the exponents? When we divide 2 powers, we subtract. Base stays the same. We subtract 2 by 5. Well, what is 2 subtract 5? Negative 3. Notice if I do it this way, I get 1 over 3 to the 3rd. If I do it using my exponent law, I get 3 to the negative 3rd. That means these 2 must be the same thing. They have to be equal. So 3 to the negative 3rd is the same as 1 over 3 to the positive 3rd. Oh, sorry, I should have done this section here. That's okay. So, how would I write? You don't have to write this down. How would I write that using a positive exponent? Look at this one. If 3 to the negative 3rd is 1 over 3 to the positive 3rd, Lucy?
Wait, are you like asking me how to write?
I don't want you to find the answer yet. I want you to just, how would you write this using a positive exponent? Go by this example.
Like, would it be like 1 over 4?
And then change it to positive. Exactly. Okay? Because I proved it here that we can do this. So if you've got a negative exponent, like we don't know how to do negative exponents. So we're going to change them to positive exponents because we know how to do those. Okay? It's kind of like, remember, we don't really divide fractions, do we? We change them to multiplication. Kind of the same idea here. So in the 2 examples above, we saw that 3 to the negative 3rd
is equal to 1 over 3 to the positive third.
Or here's another way to look at it.
Okay? What we do whenever we have a negative exponent,
Change the base to a fraction. How do you change anything to a fraction? Toss it over 1.
how do I make this a positive exponent? Flip it. Take the reciprocal, flip it.
And it becomes 1 over n to the positive second.
Which is just the same as, well, 1 to the n is always going to be 1, whatever over x to the n.
So whenever you have one of these, change it, change the base to a fraction, flip it, make the exponent positive, and figure it out from there.
So let's look at a couple of examples. This is the same as 3 over 1.
Didn't change the exponent yet. All I did was write 3 as a fraction. Now, how do I write it using a positive exponent, Zara?
You do the reciprocal.
Flip. And it allows me to make it positive.
Which is the same as 1 over 3 squared.
What is 1 over 3 all squared? 1 over 9. Done.
Second one, it's already a fraction. So I don't have to make the fraction.
How do I change it to positive?
Flip it. So what does it look like, Olivia?
4 to the third over 3 to the third.
Yeah.
4 over 3 to the third, or 4 to the third over 3 to the third?
60.
64 over 27. Oops. 7. Got to make this base fraction. How do you make it a fraction? Toss it over 1. What's this going to look like as a positive exponent?
-2.
1 over -2, and it allows me to change this to 4. One to the fourth, 1.
-2, it's in parentheses. Be careful. 16.
Not -16,
Positive 16, because it's -2 times -2 times -2 times -2. Okay? That's how we do negative exponents. Change them to positive before you figure out the value. Now, what if we combined what we learned last lesson with negative exponents? What if I asked you this?
Say the question.
Yeah.
What's that? Did we skip a question? I don't think so, did I? Oh, sorry, yeah. Thank you. Yeah, so now we've got a negative exponent and a fraction. Well, let's deal with the negative exponent.
Write the 25 as a fraction. Notice I haven't changed the exponent yet. What would this look like if I wanted to change the exponent to positive 1/2? Look at it.
Do you remember what to do now?
Basically, 1 over square root 25.
Yes. Remember, how do we change this? We got to change it to radical, right?
Remember how we did that? Well, denominator is 2, so it's going to be square root of 1/25.
That's what we learned the last lesson.
So what's the square root of 1 over the square root of 25? Done.
So notice when it's got negative and fractions, do the negative first, change it to positive, then do the fraction exponent by changing it to radical. What would be your first step here?
Like, flip it again so that the exponent becomes positive.
Okay, so you're gonna go 1/8 to the 2/3.
And then,
Remember, you could write this step first. You don't have to. But you could write that step first if you wanted to. Okay, keep going, Lydia.
8 to the cube root, and then up in brackets, and then outside the brackets square.
Right. Remember how we change it? The denominator becomes the root. And if there's a numerator, we have to raise
It to whatever that exponent is in the numerator.
So the cube root of 1/8 is cube root of 1 is 1 over the cube root of 8, which is 2. And I still have to raise this to the second power.
1/4.
And that becomes 1/4. Okay?
These are the most complicated ones you're going to see. Okay? Where you've got to do fractions and negatives.
This one's already a fraction. How would you write this with a positive exponent?
Somebody over here.
How would you write this with a fraction, positive exponent?
Would you still do the same thing?
Flip it.
You're gonna be 16 and then 9.
Yep,
Exactly.
now we gotta change it to root. What goes here?
2,
2,
so it'd be 2
and then
and then it'd be 2,
raise to the,
2,
not 2,
okay.
3. Good.
That's right.
Now let's do this. Square root of 16
4,
over square root of 9. And then I still gotta cube that. 64/27. Good job.
I thought I changed my, this is not the same example. Okay, let me just, let me quickly, let's see if I can do this. Yeah, sure, I'll save it. Okay. Let me get this one in here. There. And there. This should be it. Come on. Oh no, that's the exercise. I want the lesson, not the exercise. Let's try this again. There we go. Okay. All this is just how do I do negative exponents on the calculator? That's all. Okay.
So the signal strength of a cell phone tower is found using this formula, where S is the signal strength and D is how far in kilometers you are from the tower. So if your phone is 4 kilometers from a tower, what's the signal strength? So I'm telling you that D is 4. So we can replace D with 4.
Proper order of operations.
What do I do first? Multiplication or exponent?
So,
Exponent. So I have to do that. Use your calculator.
it's 0.0625.
0.0625.
Yes.
Okay, good. And now multiply that. And we should get 6.25. So that's the signal strength.
Okay, so it's, you guys already know how to enter exponents into your calculators, or you should know. Okay, so all we did was one with a negative exponent. Notice it still works the same as if they were positive exponents.
Okay, good.